Okay, we're going to look at this leg right here, WAN technologies switched, packet switched, and then these technologies. Now, most of these were before the internet. These were typically through the telephone system. However, the internet was on its way up, and the last one that we're going to look at today, which is not listed here, MPLS, actually was after the internet was around. Now, we're not going to do these justice. This is a 10,000-foot view of these things, but let's take a look at them. X25, the very earliest. This is a kind of a layer 2 technology, although remember we didn't have the OSI model yet. So we say that it actually had protocols that were kind of layer 1 like, layer 2 like, and layer 3 like. The layer 2 did a lot of error checking. In fact, X25 was renowned for error checking. It kind of slowed it down, but it made 100% certain that everything arrived safely. It kind of looks like this. You have data terminal equipment, that's your computer or server or whatever it is, and then that data terminal equipment had to connect at the phone company to DCE, which is a data circuit terminating equipment. That in turn was passed into this sort of cloud thing. Now, the reason that this is put into a cloud is that X25 only specified this portion of it. It only specified the protocols to get from the DTE to the DCE, and then from the DCE to these switches. But these special X25 switches were all done by the phone company, although they were not part of the actual protocol for X25. And so this was done on other protocols inside this cloud, and we didn't really care how that cloud worked. And that's really how X25 worked, except remember that the addressing and this error checking as it came out of one of these things and came back to a piece of equipment, if it was not absolutely perfect, it would ask for a retransmission and it would have to retransmit it. All right, let's go back to this again, and we're going to look at frame relay. Frame relay operates almost entirely on the layer 2 layer. It uses something like a layer 2 address, which is a MAC address, except it's not a MAC address. It's a DLCI number, data link connection identification number. So in this case, what I would do, let's go to the next slide, I will actually give each of these routers out here a DLCI number. And then again, we have DTEs and DCEs. This protocol again also only talks about how to get from the DTE to the DCE. The DCEs in this case are inside of this network, and really we don't even care how those work. And then we go from these DCEs to frame relay switches. And again, these are specialized switches that would have been set up. They can be set up on routers, like IP routers that we typically use today, or they could be set up by the phone company on specialized switches. We don't care about the protocols in there, although there are other protocols on how to set up these frame relay switches. One of the things you do in a Cisco study is to set up frame relay on Cisco routers, and it can be done. But remember that the protocol itself only calls out how to get from this DTE to the DCE, and it uses these DLCI numbers. I would assign a DLCI number to this, a DLCI number to this, a DLCI number to this, and that's how we would route these things through these switches to get from one point to the other point. The third one is ATM, asynchronous transfer mode. Now, it didn't use typical frame or packet type chunks. It used something called cells. These cells were all exactly 53 bytes long. Now, 5 bytes were addressing and header information. The other 48 bytes were the actual data. The nice thing about ATM was that because they were all the same size, we didn't have to worry about the switches in between trying to figure out the length, and so there weren't the delays that the others had. This was actually the first time we were able to carry video across WANs. The network looked kind of like this. So you would have all these users out here, and then those users would share a private ATM switch at the phone company. And then the ATM switch would go through the public ATM network. This was a separate network from the phone network or from the internet. However, it was usually held and kept by the phone company. So you could then get to this network and then back to the switches to maybe a server over here. These were actually, it's kind of funny, ATMs were actually used a lot for ATM machines. It doesn't have the same meaning. They're totally not related, but ATM machines and credit card machines often use the ATM network in order to do that. And in those cases, they might be always on. In other words, they might have a connection that's always there in a large city, but then out in the country somewhere where they're hardly ever used, they might not have an always-on connection, and they would have to establish a connection prior to the transfer of that data. The last one is MPLS. Now, MPLS came along, multi-protocol label switching came along after the internet was well established. And it looks something like this. It just kind of looks like an internet, doesn't it? Well, it kind of is, and it uses these routers, except rather than the standard routing table that these things build, we're going to put on these things sort of a special routing table that is a layer 2 routing table. And the layer 2 routing table has addresses, so we're going to give each of these devices down here, the actual end devices, and the routers in some particular path. So we're going to say if I want to get from here to here, I'm going to establish a specific path to get there. And I'm going to give all of these routers here a special layer 2 routing table that relates to the layer 3 routing table. But the nice thing is here that as this packet moves from this router to this router to this router, it doesn't have to open up the packet, strip off the layer 2 data, look at the layer 3 data, and then package it all back up with new layer 2 data, and then send it on to the next router. It doesn't have to do that because it has an exact circuit built into it using this special routing table in order to get from this point, which has a layer 2 address, to this point, which has a layer 2 address, and it can just take that path and not have to stop at each router, open it up. So that's supposed to save time. Now, with today's internet technologies, you don't really save that much time anymore, but that's the way it worked. And it's multi-protocol because it's going along these layer 3 devices, but it's going along using a layer 2 address. It's quite interesting how it does it. But we don't use it very much anymore because it just doesn't save us that much time anymore.